card. There. Right here. There we go.
The loss of electrons from a substance involved in a redox reaction.
Flashcards just to go over all of the vocabulary from the electrochemistry unit. It's pretty basic. Okay. Oxidation.
The gain of electrons from a
Reduction.
Substance involved a cell in which energy released from a spontaneous chemical reaction is used to generate electricity.
Galvanic cell, anode, cathode, cell potential, standard reduction potential, standard reduction equation. What happens if the cell potential is greater than 0? How do you determine the half reaction is a cathode or an anode, which is the most important part of that? Those problems is determining which one goes first. Definition: okay. Primary battery, secondary battery, lead acid battery, fuel cell, corrosion, electrolysis, and that's it. And then we have a quick little practice problem to go to, and that'll be it for today. Just a little short thing. But I was hoping we had a few more people so we could have some back and forth on these. You can either just put in the chat or whatever, but just the definition of each term as it comes up.
Okay. So oxidation, that's the I'm trying to remember, like oil rig, so that's the loss of electrons, right?
Is the loss of electrons from a substance involved in a redox reaction.
Okay.
Leo.
Sorry.
Loss of electrons. Oxidation stands for, or it's for Leo. That's the easy way to remember what oxidation is. Then you go to reduction, and it's the gain of electrons. So GER. I do Leo and GER. So GER reduction, gaining electrons. Galvanic.
That
is a cell in which energy is released from a spontaneous process or spontaneous chemical reaction, and it's used to generate electricity. That's in just a basic definition. You probably won't be quizzed on that definition, but you might be quizzed on like what is an oxidation. So it's good to remember those two. This one, it's just kind of a baseline understanding. Anode and cathode. So that the anode, remember if you think of the valves that connect, so the anode is the electrode where the oxidation occurs. So
the electrode at which oxidation occurs.
And then your cathode, since it's a consonant, it's the one where
the electrode at which reduction occurs.
Together and the valves go together. Reduction at the cathode, oxidation at the anode.
Okay.
And then the cell potential. Cell potential, this is another one. This is just a baseline definition. The voltage between two half cells in a electrochemical cell. So this is what you solve for. It's the cell potential.
Right.
The standard reduction potential is E0 of the cathode or the anode. It specifically relates to those half cell reactions. And then the standard reduction equation. This is the the cell potential is equal to the two standard reduction potentials. And it's the important thing to remember is that it's the cathode minus the anode. And so you'll be given on most problems, you'll be given one chemical equation, and you have to break that down into the two half reactions. And then you have to look at the chart and see which one is the cathode and which one is the anode. And the way you need to know that is the next question. How do you determine which half reaction is the cathode or the anode? So you know that the number values go into the equation, but you don't know which one is which. The way to determine that is the cathode half reaction will be written exactly how it appears on the table, and the anode half reaction will be flipped. So you're given a table of a lot of values and the equations, and you're going to look and try and find both equations on there. And one of the equations is going to be written exactly how you wrote it, with the products on the left and the reactants on the right. And then the other equation is going to be written with the reactants on the left and the products on the right. And so if it's that one, the second one with the products on the left, then it's going to be your anode. It's going to be flipped from what you have. And if it's written exactly how you write it, it's going to be the cathode. And remember, the cathode goes first. So you find the one that's exact, and then you subtract the one that's not exact. You don't change any of the values themselves. You just find out which one goes in front of the other. And then if the cell potential is greater than 0, then the reaction is spontaneous. Definition of a battery. I don't remember being quizzed much on batteries, so I don't think this is really an important part of the unit per se compared to the other ones. But we're still going to go over the definition, just kind of get an overall grip on everything. So definition of a battery is a galvanic cell or a series of galvanic cells. So just know that a battery is a galvanic cell, or a galvanic cell is a battery, I guess. And then a primary battery is the non-rechargeable normal battery. So just AA's that you buy at the store, that's going to be a primary battery. Your secondary battery are the rechargeable batteries. My grandma always uses these, so that's kind of how I remember it. The secondary battery is rechargeable, and you don't really need to know anything beyond that, I don't think. So just non-rechargeable is the primary, and secondary is going to be your rechargeable battery. Then your lead acid battery, it's going to be your car battery in which the lead is used. It's going to be a 12-volt battery. I don't remember being tested on that at all whenever I took this class, so you should be fine.
Okay.
Fuel cell is a voltaic or a galvanic cell. Voltaic and galvanic mean the exact same thing, so don't worry about that. But a galvanic cell with constant potential just means it doesn't get used up. Corrosion, it's rust, the chemical oxidation of metal. Iron rusts if you get it wet, and that's all corrosion is. Then electrolysis, the last definition we got. It's a process by which an electric current is forced through a cell and breaks chemical bonds. She kind of covered it right at the end. You don't really need to know about the process. This is what the example problem is over. You don't need to know necessarily the definition as much as you just need to know how to do the problem.
Okay.
Exactly what we're going to do. But just remember, electrolysis is when you're forcing the electric current through the cell and it's breaking chemical bonds. But here's the practice problem. So she gave us one similar to this in the lecture, and I changed them just to keep it a little interesting. But yeah, so you have everything you need here to solve it. It's how many grams of magnesium can be produced from magnesium 2+ ion using a 75 amp current over a period of 72 hours. And then, I didn't put the units on this. This is amp seconds.
Your screen is still on the Quizlet on my end.
Divided by, what was it? Moles of electrons. Okay, that's the units for your Faraday's constant. Remember, this will always be given in a problem. The molar mass won't necessarily be given, but you'll be given like a periodic table or something where you can find it. I just put it here because it's going to be a lot easier than trying to find it later. But yeah, this is all you need to solve the problem. You just need the time, the amp current, the amount of ion or electrons, the Faraday's constant, and the molar mass. So knowing that, we'll start from the top. So what you're going to want to make a table like she did in the problem to solve it, just to cancel out your units. It makes it a heck of a lot easier. So we're going to start with the amps. Actually, the best way to start might be with the Faraday's constant, the best way to remember it. So you're going to start with Faraday's constant. It's the 1/96485 amp seconds per mole of electrons. There we go. And the reason that's on the bottom is just so it can cancel out the units easier. because then we go to 75 amps. So now we're just focusing on canceling out the units. So we want to cancel out the units. We have amps, we have seconds, we have moles of electrons. So we need to look. We have amps right here, so that'll cancel out the amps. We have hours, so we need to convert that to seconds to cancel out the seconds. And then the moles of electrons is found right here from the 2+ ion. So we'll keep going. So it's 75 amps, and we'll just put that over 1. And then we need to cancel out the time. So checked. But, oh, the screen. Oh, I'm sorry. My bad. There we go. Is it good now? Okay. Yeah, that's fine. I had the chat box up, but then I had to delete it when I changed the page, but I'll have it up now. So if you need to say anything, it's up there. But here, I'll walk you through it again. So we have amps, hours, 2+ ion, Faraday's constant, and the molar mass. And then we put up this table, and we're doing 1 over Faraday's constant to cancel out the units. And that's what we're starting to work on now. So we have 75 amps, and then the hours, we need to convert to seconds. So we're going to start with 72 hours over 1. And then 1 hour, to cancel out the hours, is equal to 60 minutes. And then 1 minute is equal to 60 seconds. And so now we're back at seconds, and we cancel out the minute. Oh, let me put that down. Cancel out minutes. Oh. Minutes. Cancel out hours because of that. And then cancel out the amps and the seconds. From right there and there. Okay, so now all we need to cancel is the moles of electrons. And remember, we're trying to get to grams. That's the only unit we want at the end of it. So now we need to cancel out the moles of electrons. So we know that we're transferring from magnesium 2+ ions, that's what we have, and we're trying to get magnesium, just the element. So we need the moles of electrons on top. So we know that there's 2 plus, no, we need with the moles on bottom. My bad. There's 2 moles of electrons. Okay. For every 1 mole of magnesium. And you just get that from right here, this 2+ ion. So if that was a 3+ ion, then it'd be 3 moles of electrons. Simple as that. But we're gonna run with 2+ ion. And then what? So we have the moles of electrons, that cancels out with right here. All right. And then we have moles of magnesium, but we don't need moles, we need grams. So we need to cancel that out using the molar mass. So we know in 1 mole of magnesium, there is 24.31 grams of magnesium. Now we cancel out moles of magnesium. And the only thing we're left with is grams of magnesium, which is exactly what we're trying to solve for. So we know we're good to just go ahead and do the math. And I brought my calculator, so let me plug this in real quick. 75 times 72 times 60 times 60 times 24.31. And then divide it by 96,485 and by 2. And we get the answer of 2,449.0 grams of magnesium. And then if we look at sig fig, we have 2 sig figs here. So it's going to be 2. And that will be, and we're going to go ahead and move it to kilograms as well, just to make it easier. So it's 2. I think it stays 2.4 kilograms of magnesium. And that's how you get your answer for the electrolysis problems. It's mainly just unit cancellation. There's really nothing much else to it. I remember whenever I got this problem on a quiz, I completely bombed it because I had no idea what I was doing because I missed the class. So I got a 0 on this quiz, but looking back on it now, it's one of the easiest things because it's literally just canceling out the units in order to get the correct answer. And that's all you need to do in order to solve for the electrolysis problems. And we already covered all of the flashcard vocabulary. So I guess I'll open up the floor to you. Do you have any specific questions about anything that y'all covered? Anything that was difficult to you? Anything you want to run over again? You can just put it in the chat if your mic's not working. Okay. All right. Well, if you're good on everything y'all covered, I've covered everything that I can cover for today. She didn't really go over too much that was quiz material. So besides that, can you just put your UID in the chat? And then that'll be it for today. Awesome. Yeah. And then I don't know how this works. I don't know if it's open up to the public or anything if you wanted it, but the video will be on my website if you need to go over it again and look at any of the terms. But other than that, we're good for the day. You're good to go. Yep. Have a good day.